This is going to be your first part of the video for 2-5, which is going to be on completing the square. Completing the square is an additional way to solve quadratics that you may not normally be able to factor. So the first thing I wanted to look at is a review of factoring PSTs. Now, PST stands for perfect square trinomial. So basically, all of these polynomials are going to factor into one set of parentheses squared, because when you set up your two sets of parentheses, they end up being identical. So you can write them as one set squared. So if we look at the first one here, I have r squared minus 10r plus 25. The traditional way that we would solve that would be we'd have an r and an r. Factors that two things that multiply make 25, but add to be negative 10 would be negative 5 and negative 5. And you can see that's the same thing as r minus 5, the quantity squared. All of these problems are going to be set up the same way, where they are all going to factor into one set of parentheses squared, and that has to do with the way that the original problem is set up. So what you have here is an a squared. In this case, it's a minus, but it could be a plus, 2ab, and then plus b squared. Whenever you factor that, that is going to be a, and in this case, minus, that sign in the middle comes from whatever's in front of the 2ab, and then the quantity squared. So you're really looking at the square roots of the first and the last terms, and that's what's going to go in the parentheses. So if we look at number 3, again, this is a subtraction question. The square root of the first term is b. The square root of the last term is 3, so this is going to factor into b minus 3, the quantity squared, because it'd be b minus 3 and b minus 3. As we look at number 5, the square root of the first term, we would take the square root of the number and the letter. This is going to be a 4x. The square root of the last term is 5. So this one is going to factor into 4x plus, notice the middle term does have that plus there, plus 5, and then squared. The middle term, which I didn't really talk about that too much, notice it is 2ab. The middle term, to be a PST, to be a perfect square trinomial, the middle term always has to be equal to 2 times the square roots of the first and last terms. So for example here, if I take 2 and multiply by the 4x, I get 8x, and then multiply by the 5, I get 8x times 5 is 40x, which ends up being the middle term. So that's why these work out this way. So number 7, again, this is a 4r, this is a 3. So this is going to be 4r plus 3, quantity squared. Over here in the other column, we have some other basic ones. This one would be b minus 1 squared. This one is going to be k minus 4 squared. This one, 3b plus 2 squared. And then there's another one down there below my little video thing, but that's not going to affect our understanding. We're going to be doing this type of factoring in the completing the square process, which is why I wanted to make sure I went over it. So now we actually have 2-5, completing the square. The critique and explain you were given in a separate assignment, and I'll do a video going over that in a different format. So we won't be doing that just right now, but that is something that I will go through and explain a little bit later on. So our essential question, how can you solve a quadratic equation by completing the square? So the first question we're going to look at is a problem that is set up to use the square root property. If you recall, back in 2-4, we used the square root property whenever we didn't have a b value. So now I'm going to show you how to use the square root property when you do have a b value. This one is already set up that the one side of my equation is a PST. It is a perfect square trinomial, so I can actually factor that. So if I factor that the way that I factored on the very first slide, it's going to factor into x plus 7 squared. Notice square root of x squared is x, that square root is 7. If I take 2 times x times 7, I end up getting the 14x that's in the middle. So now that I have a problem like this, when you have something squared equal to something else, you can solve that by taking the square root of both sides. When you do the square root property, though, you do have to put down the plus or minus just on one side. You don't have to put it down on both. And then on the right-hand side, the square root of a set of parentheses squared is whatever you have inside. So plus or minus 5 is equal to x plus 7. I would subtract the 7. I have to put it out in front. And that's going to be equal to my x. So instead of writing two equations here, like 5 is equal to x plus 7 and negative 5 is equal to x plus 7, I can write the plus or minus there. Subtract the 7 over, I have negative 7 plus 5 and negative 7 minus 5. I'm going to get two answers for x. So x is equal to negative 7 plus 5 would be negative 2. Negative 7 minus 5 is negative 12. So I get two answers. This is an additional way to solve. Because of the nature of the answers, this is one that we could have actually factored. I could have subtracted the 25 from both sides, gotten the 24 on at the end in the C position, and then we could have gone through and actually factored that. But completing the square will work even when your question does not factor. And this is the process that we're going to be using to complete the square. The highlighted term here, the b over 2 squared, that is going to be the key to completing your perfect square trinomial. So when we say completing the square, we're basically completing the s in the perfect square trinomial. So we're making sure that rather than just a trinomial, it is actually a square trinomial. So that it factors into the one set of parentheses squared, and then we can use the square root property to solve. So again, that b over 2 squared, that's going to be the key to this. Now we have this question. This one isn't really asking us to solve, but I am going to go through and solve this one the whole way so you guys can see how this works. We have x squared plus 8x plus 5 equals 0, and it just says to write it in this form. X plus p squared is equal to q, but I'm actually going to go through and solve for x. So I am going to do a little bit more than what it asks me to do. So here's your process. The very first thing you need to do is take whatever c term you have. Notice 5 is not a perfect square, so I know this is not a PST to begin with, and I need to move that to the other side. So I have x squared plus 8x is equal to negative 5. You also need to make sure that the coefficient in front of your x squared is 1. If it's anything other than 1, including a negative, you need to divide every term in the problem by whatever that coefficient is. This one is a 1, so we're good to go. Next, you need to identify your b term. Well, in this case, my b term is a positive 8. 8 divided by 2 is 4. 4 squared is 16. So 16 is the magic number that is going to complete the perfect square trinomial. But if you recall from your rules about equations, I can't just add it to the left-hand side and be done with it. To keep my equation balanced, I have to add it to the right-hand side as well. We are allowed to add 16 to the left and to the right because then everything stays in balance like it's supposed to be. So once you add that b over 2 squared term to both sides, the one side should be a perfect square trinomial. You need to factor that. So that's going to factor into x plus 4. On the right-hand side, we are going to combine. So negative 5 plus 16 is 11. This is where this question would normally stop, but because I want you guys to go through the whole process, I am going to go through and solve this. So we're going to continue with the square root property. So take the square root of both sides. And I don't need to put that parenthesis down once I do my square root. So I have x plus 4 equals plus or minus. You still have to put that down, even though I can't take the square root of 11. And then we would finish that out by subtracting the 4. And I'm going to write that up here. So I have x equals negative 4 plus or minus the square root of 11. You can leave your answers like that, or you do need to make sure, though, This is the same thing as x equals -4 plus the square root of 11, and x equals -4 minus the square root of 11. So both of these answers are written as one continual statement with what's boxed in. And that's completing the square. You may come across some questions that give you I in your answer. You may have to simplify some square roots. You may get rational answers like we did in example 1. It just all depends on how the question is set up. Completing the square is very useful for this question because there is no way this would factor using regular rational coefficients, because there are no factors of 5 that add to make 8. So this is why this is very important to use this process. Okay, so now this is example 3. We're going to go through and do this by completing the square. So we're going to do the full process here. First thing you want to do is move your C term to the other side. And this one, I know you have everything on the right, so I'm going to go ahead and move my 3 over to the left, and then it becomes negative. Then you identify your B term. Well, my B term in this case is -2. -2 divided by 2 is a -1. Squared is a +1. And then just like we did before, we're going to add that 1 to both sides of our equation. So -3 plus 1 equals x squared minus 2x plus 1. Simplify the side that does not have the x's. Factor the other side. And then we're going to finish by taking the square root, using the square root property. So on the right, I have x minus 1. On the left, I am going to have plus or minus. I took the square root of the negative. I can't actually take the square root of 2, though, so the only thing I have to do is pull out that I. So this is going to be I square root of 2. Add the 1 to finish this off. Always put the 1 in front of the plus or minus, or whatever number you have in front of the plus or minus. So we have 1 plus or minus I square root of 2, and that's my solution, or solutions for x, because it's 1 plus I square root of 2 and 1 minus I square root of 2. Again, if there had been a number in front of the x squared, we would have to divide by that number in order to make that coefficient 1. And I may try to pull in one of those examples whenever we look at some of the other work in this section. So this is going to wrap up the part 1 video. Please go back through, watch about how to complete the square, and contact me if you have any questions.